Welcome to The Explainer. Today, we're diving into something pretty huge, how Cisco is tackling a multi-million-dollar problem for their customers. The challenge? Figuring out how to stop simple network updates from causing catastrophic outages. And their solution involves a team of AI agents and a perfect digital replica of the network.
So let's start with a question that keeps a lot of network engineers up at night. What if you could see a disaster coming before it ever happens? Because, every business runs on its network, and making even a tiny change can be incredibly stressful. One wrong move, and the whole thing could come crashing down.
And this wasn't some abstract idea. This was a real question from a real customer, posed directly to Cisco's incubation group, Outshift. They were basically saying, look, we have to make changes, but we can't afford the failures. Can AI help us solve this? It's a fundamental problem about reducing risk.
So here's how we're going to break it all down. First, we'll look at the high-stakes problem itself. Then, the three-part AI solution they came up with. We'll dive into how they built the network's brain, meet the team of AI agents, and then see the whole system in action. Finally, we'll look at what this means for the bigger, open future of AI agents.
All right, first up, let's really dig into why this is such a big deal. Why is changing a network such a difficult and, frankly, kind of terrifying thing to do?
Here's the thing. Modern networks are just unbelievably complex. The old ways of doing things, with rule-based automation and simple scripts, they just don't cut it anymore. You simply can't write a script that can predict every single possible outcome. And this is exactly the gap where the Cisco team realized AI agents could be a total game changer. Okay, so with this huge problem right in front of them, the team at Cisco started to sketch out a vision. They landed on a solution that's really built on three core pillars.
And what they came up with is this really elegant three-part solution. First, you need an easy way for people to just ask for what they want, using natural language. Second, you need a team, a multi-agent system of AIs that can actually do the work. And third, and this is the crucial part, you need a safe place for them to test everything out, a digital twin, a perfect replica of the live network.
Now, let's talk about that third piece, the digital twin, because honestly, this is the foundation that the entire system is built on. This is the network's brain.
And I want to be super clear here. This is not just some fancy flowchart or a static diagram. Think of it more like a flight simulator for your network. It's a living, breathing, dynamic model, all built on something called a knowledge graph. It's a virtual sandbox where the AI agents can go in, ask questions, and test changes without ever risking the real thing.
Sounds great, right? Well, actually building one of these things is a bit of a nightmare, because real-world networks are, they're a mess. You've got hardware from a dozen different vendors, all kinds of devices like firewalls and routers, and they're all spitting out a flood of data in different formats, arriving in different ways. The challenge was to take all that chaos and turn it into one unified, understandable model. So the engineers had a big decision to make. What database technology do you use to build this brain? They looked at the options. Neo4j was a big leader in the space, but they ended up choosing ArangoDB. Why? Well, partly for what the team called historical reasons. They'd already used it for other things, so they knew it well. It was a practical, pragmatic choice, but they're still keeping an eye on Neo4j for the future. So what they landed on was brilliant. They decided to build this knowledge graph in layers, and they standardized all that messy data into a single schema called OpenConfig. Now, the key thing about OpenConfig is that it's well-documented and super easy for large language models to understand. This layered approach means an AI agent doesn't have to search the whole brain. It can just query the specific layer it needs, which is way more efficient. All right, so we've got the brain, the digital twin is in place. Now, who's going to use it? It's time to assemble the AI crew that's going to get the work done. And this is where it gets really cool. They didn't build one giant monolithic AI. Instead, they built a team, a crew of 5 specialized agents. You've got a central assistant that's like the project manager, figuring out the plan. Then you have other agents that are experts in specific things, like querying the brain or running tests. They all work together, each playing their part.
Now, there was a really important lesson they learned along the way, especially with that query agent, the one that talks to the brain. At first, they tried a common AI technique called RAG, but it was kind of like asking the AI to read an entire encyclopedia just to answer one simple question. It was slow, and it used up a ton of computing resources, which cost money. So they switched gears and decided to fine-tune the model, teaching it the specific schema and giving it examples. And the result of that switch? It was massive.
We're talking a drastic reduction in how many tokens they were using and how long it took to get an answer. This wasn't just a small tweak. This optimization made the entire system faster, smarter, and way more cost-effective. It was a huge win.
Okay, we've talked about the brain, we've talked about the AI workforce, so let's put it all together. How does this system actually solve that original high-stakes customer problem? Let's see it in action. We're going to walk through a super common, everyday scenario that can still be really nerve-wracking. A network engineer needs to change a firewall rule for a new server. It's a routine task, but if you get it wrong, you can accidentally cut off access to critical applications.
So it all starts when the engineer creates a ticket, just like they normally would. But here's where it changes. Instead of that ticket sitting in a queue, the AI agents immediately spring into action. They assess the impact of the change and write up a report. Then, they generate a full test plan. They run those tests, safely of course, on the digital twin. And finally, they attach a final report with all the results. The whole manual, error-prone process becomes this safe, automated, and totally verifiable workflow.
Okay, this is obviously a huge deal for network management, but let's zoom out for a second. Why does this matter beyond just Cisco? What's the bigger picture here for the future of AI?
And it really boils down to a couple of huge takeaways from this whole project. First, that idea of a knowledge graph, that digital twin, that's the key to letting AI safely interact with any complex system, whether it's a network, a supply chain, or a power grid. Second, for these AI agents to really work together at scale, they need a common language. They need open standards. And that's why Cisco is backing an open source project called agency.org to help build that future.
And that final point is the one that really gets you thinking. This project isn't just about solving one problem. It's a glimpse into a future where specialized AI agents, built by totally different companies for different jobs, can all collaborate and work together seamlessly. So the real question it leaves us with is, what could a global team of intelligent, cooperative AI agents actually achieve?